In the lightless depths of the cosmos, where silence reigns and time stretches toward infinity, something unfathomable has begun to whisper that our understanding of reality is flawed. The James Webb Space Telescope, humanity's most powerful eye, has looked deeper into the universe than any machine before it, and what it has revealed threatens to upend every cosmic law that scientists once thought immovable. For decades, astronomers believed the expansion of the universe could be neatly charted and explained. The Hubble Space Telescope gave us one set of measurements, mathematical theory supplied another, and for a time the numbers seemed to harmonize like the notes of a well-tuned symphony. Then Webb turned its gaze into the farthest reaches of darkness, and that elegant harmony shattered into discord. The universe, it seems, is stretching at two different rates, as though space itself is torn between contradictory rhythms. Imagine an enormous balloon swelling unevenly, one hemisphere inflating twice as fast as the other. Physics tells us this cannot happen. Expansion should be uniform throughout the fabric of existence. Yet Webb's precision confirmed the nightmare that had been haunting cosmologists for years. Measurements derived from distant pulsating stars known as Cepheid variables produced one figure, while calculations based on the faint afterglow of the Big Bang, the cosmic microwave background, gave another. The discrepancy is vast, not a minor statistical quirk, but a rift so wide that it calls into question the very scaffolding of modern physics. Researchers call this contradiction the Hubble tension, though the term hardly captures the existential dread it inspires. It is not a mere calibration error. Thousands of observations across multiple galaxies, each spanning hundreds of millions of light-years, confirm the same impossible truth. Either our models of the cosmos are catastrophically incomplete, or some hidden force is rewriting the rules of reality. The concept of dark energy, that mysterious agent believed to drive the universe's acceleration, may be far stranger and more volatile than anyone dared imagine. Perhaps different regions of space expand at distinct speeds, ripping subtle seams into space-time itself. Adam Rees, one of the principal architects of this revelation, admitted bluntly that with all sources of measurement error eliminated, the only remaining explanation is that we have misunderstood the universe at a fundamental level. To call that realization exciting is a cruel understatement. If our grasp of cosmic expansion is wrong, then every calculation, the age of the universe, its size, even its fate, rests on quicksand. Webb's unmatched clarity leaves no refuge in uncertainty. The data are consistent, the contradiction undeniable. Two truths coexist, both verified and yet irreconcilable, as if the universe were playing a cosmic trick on its observers. Imagine learning that gravity sometimes repels, or that light occasionally travels backward. Such is the scale of this scientific dissonance. The telescope has not merely exposed a flaw in our equations, it has revealed a flaw in the way we think about existence. Dark energy might be evolving through time, pulsing or decaying in ways we cannot yet describe. There may be interactions between regions of space that alter the rate of expansion, like currents within an invisible ocean. If that is the case, the universe is not the smooth, predictable continuum our textbooks portray, but a restless sea of distortion and imbalance. This revelation also hints at something even more disturbing: the possibility that the cosmos is fracturing along unseen boundaries, that space-time itself could be anisotropic, structured, directional, and alive with hidden asymmetries. The implications ripple through every corner of cosmology. A variable expansion rate would mean the early universe unfolded differently in different directions, altering how matter clumped, how galaxies formed, and perhaps even how time flows on the larger scales. Webb's findings suggest that cosmic history may not be a single unified narrative but a patchwork of regions, each obeying slightly different rules. If true, then our familiar constants are not truly constant at all. Scientists now face an uncomfortable choice: either abandon cherished assumptions about the uniformity of the universe, or invent entirely new physics to reconcile the data. Some speak of exotic particles influencing expansion. Others propose that what we perceive as dark energy might be an illusion born of higher dimensional geometry. Whatever the answer, the certainty once anchoring cosmology has dissolved. We are left with the haunting realization that our universe is not behaving as it should, and perhaps it never did. Webb's first glimpse into the deep past has transformed curiosity into crisis, turning the heavens into a mirror reflecting the limits of human comprehension. the cosmos has presented us with a riddle whose solution may require rewriting reality itself, and the only honest response is awe tinged with dread. When the Webb telescope turned its mirror toward a region of space barely older than 500 million years after the Big Bang, it found monsters where only cosmic infants should exist. 6 immense galaxies shimmered out of the void, each packed with stars so dense and mature that they violated every established model of how quickly the universe could have built such colossal structures. These were not faint embryonic smudges of gas. They were titans, as massive as the Milky Way yet formed when the cosmos was still in its youth. According to every computer simulation and theoretical projection, such galaxies could not have assembled so early. There simply had not been enough time for matter to cool, coalesce, ignite, and evolve into the ordered spirals and ellipses now staring back at us from 13 billion years ago. Scientists dubbed them the universe breakers, a name as dramatic as their defiance of expectation. Each one seemed to compress billions of solar masses of stars into a fraction of the time nature should allow, suggesting that gravity, dark matter, or some unknown ingredient was working overtime. The shock was not only in their size but in their maturity. These galaxies contained heavy elements, structured cores, and organized rotation, all hallmarks of long, gradual evolution. Yet they appeared at an age when cosmic history had barely begun to write its second sentence. If the early universe could form such giants, then our chronology of creation is wrong. Perhaps the first galaxies were not small, chaotic clumps as once believed, but immense structures born in a flash, sculpted by forces we have yet to comprehend. One possible culprit is dark matter, the invisible substance thought to outweigh ordinary matter 5-1. If dark matter behaved differently in the universe's infancy, clumping faster or interacting more strongly, it could have created gravitational wells that pulled gas together at breathtaking speed, birthing galaxies overnight on cosmic scales. But that explanation, while tempting, requires rewriting the laws that govern dark matter itself. Observations from Webb show that these ancient galaxies emit light so redshifted and so luminous that even the boldest theories strain to account for them. Some astronomers propose they might not be galaxies at all but something stranger. Perhaps clusters of primordial stars so massive they mimic galactic brightness, or the glimmering halos of early black holes feeding with ferocious appetite. Others whisper that our measurements of distance and age may conceal a more profound distortion, that space-time could be warped in ways we do not yet understand, causing youthful galaxies to masquerade as ancient ones. Whatever the case, the discovery shattered confidence in the gradualist view of cosmic evolution. Webb's images revealed a universe that did not creep into complexity. It leapt. Matter organized itself with almost arrogant speed, forming the first cosmic cities while the background radiation of the Big Bang still echoed across space. Theorists are now forced to reconsider the sequence of cosmic milestones. The birth of the first stars, the accumulation of heavy elements, the ignition of nuclear furnaces, and the sculpting of galactic forms may all have happened far earlier and faster than anticipated. If true, the early cosmos was not a dim nursery but a roaring forge. The universe breakers stand as silent witnesses to that frenzy, their starlight carrying the signature of impossible haste. Each observation compels us to question whether our physics can handle the raw creativity of nature. Perhaps dark energy or quantum fluctuations amplified growth in ways we cannot yet simulate. Perhaps the laws that appear stable in our mature universe behaved wildly under the pressures of its birth. What unnerves scientists most is how methodically the anomalies multiply. For every early giant found, another soon follows, hinting that such galaxies were common, not rare exceptions. If that is so, then the cosmos had a head start of hundreds of millions of years on our models. The clock of creation began ticking long before the Big Bang's afterglow cooled, or perhaps our very concept of time misbehaves at those scales. The 6 colossal systems Webb unveiled are now joined by more candidates, each demanding new mathematics and new humility. It may be that matter itself had more avenues for condensation than we imagined, or that gravity cooperated with exotic particles to accelerate formation. Whatever mechanism sculpted them, the result is undeniable. The young universe was older than it should be. These galaxies, blazing defiantly against the darkness of the first epoch, remind us that our cosmic narrative is provisional, our equations fragile before the enormity of what is real. In the end, the universe breakers are less a mystery to be solved than a warning whispered across billions of years that the universe does not owe us consistency, only astonishment. Amid the cosmic wilderness where galaxies shimmer like scattered embers, Webb found something that should not exist, a supermassive black hole drifting alone, stripped of a host galaxy, shining through the dark like an exposed heart in the void. Astronomers call it a Q-son, an object so bizarre that it challenges the very definition of how black holes are born and how they evolve. Every known supermassive black hole anchors the center of a galaxy, fed by the swirl of stars and gas that orbit it. But this one floats in isolation, detached from any visible structure, as if it were ejected from the universe's architectural plan. Its gravity must be immense, yet the surrounding region shows no signs of the galactic host that should accompany such mass. Some scientists speculate that we may be witnessing the first generation of black holes, the primordial kind, born not from collapsing stars but from the direct collapse of colossal gas clouds mere moments after the Big Bang. If true, these entities predate galaxies themselves, acting as cosmic seeds that later drew matter toward them, shaping the universe's skeleton. The idea is as elegant as it is terrifying, black holes as the architects of creation rather than its aftermath. This Q-son may be one of those ancient titans, a survivor from a time before stars even existed, revealing that the first lights of the cosmos may have emerged around darkness rather than into it. Yet its solitude raises deeper questions. How could such a massive object wander freely, unmoored by the gravitational cradle of a galaxy? One possibility is that it was flung into intergalactic space during a titanic collision. When two galaxies merged, their central black holes may have spiraled together, and in the violence of their union one was hurled outward at unimaginable speed. If that is the case, then the Q-son is a cosmic exile, a refugee travelling through eternity, dragging with it an invisible cloak of distorted space. Another explanation stretches further into speculation, that these naked black holes formed spontaneously from quantum fluctuations in the early universe, collapsing regions of overdense energy that never had the chance to become stars. Such objects would be fossils of creation, older than any galaxy, embodying the raw physics of the Big Bang itself. Webb's instruments, designed to capture the faintest light from the dawn of time, have now glimpsed the radiation around this orphaned void. The glow is faint but steady, an accretion disk of gas spiraling into oblivion. The energy it releases rivals entire galaxies, defying the assumption that solitary black holes must starve. It feeds, somehow, perhaps from the diffuse intergalactic medium, drawing sustenance from the thin soup of atoms between galaxies. If so, these wanderers may be far more common than we think, invisible predators drifting in the cosmic dark, shaping the evolution of galaxies they never belonged to. The discovery of a naked black hole also forces scientists to reconsider how the first supermassive black holes appeared so quickly in cosmic history. In theory, it takes billions of years for a black hole to grow to millions or billions of solar masses through ordinary accretion. Yet Webb observes gargantuan black holes already present less than 1 billion years after the Big Bang. The math doesn't fit. Primordial collapse models, once fringe ideas, are suddenly gaining weight. These theories suggest that under certain extreme conditions, vast clouds of pristine hydrogen could skip the star phase entirely, collapsing straight into black holes. If the Q-son is one of these, it is a relic from that first chaotic epoch, when gravity sculpted matter without intermediaries. It might even explain the mysterious excess of high-energy radiation observed throughout the universe. The faint X-ray background could be the collective whisper of countless hidden black holes feeding in isolation. What chills astronomers most is the notion that these primordial voids may still roam our universe today, undetectable until one strays close enough to disturb the light of distant stars. The naked black hole Webb uncovered could be one of many, drifting silently through intergalactic space, a reminder that darkness came before light and may outlast it. In the grand ledger of existence, they are both destroyers and creators, erasing everything they touch, yet shaping the galaxies that emerge from their influence. The Q-son stares back at us from the beginning of time, not as an aberration but as a clue, that perhaps the universe itself began as a collapse rather than an explosion, that every galaxy is merely the luminous residue of ancient darkness. The more we learn, the less certain we become that light is the foundation of reality. In truth, it may only be the echo of something far older, something that feeds eternally on the fabric of being itself. In the endless dark where galaxies drift like ancient embers, Webb's gaze found a cosmic ballet frozen at the edge of eternity. Two galaxies caught in the act of collision, their luminous arms interlacing like molten rivers of starlight. Astronomers named the system informally the Infinity Galaxy, because its spirals loop together in a pattern eerily reminiscent of the symbol for eternity, a glowing figure eight carved into the night. Yet beauty is only a disguise for violence. What Webb captured was no tranquil dance but a cataclysmic union, an event so powerful that it could create a black hole instantaneously, bypassing the slow, patient evolution that textbooks once described. For the first time, humanity was witnessing what theorists had only imagined, the direct collapse of a galactic core into a singularity, not over eons, but in a cosmic heartbeat. In the merging core of these two galaxies, matter spiraled inward at unimaginable speed, compressing until gravity won its eternal argument against all other forces. There was no gradual accumulation of mass, no centuries of accretion. Instead, the gas and dust of two colossal systems funneled into a gravitational whirlpool, forming a supermassive black hole in what could have been mere millions of years, a blink in cosmic time. This was creation through annihilation, a process so violent that even light itself struggled to escape the chaos. Webb's infrared sensors revealed the telltale signature, a luminous ring surrounding a dark void, glowing fiercely in wavelengths no human eye can see. It was proof of a theoretical event that had long hovered between myth and math, the birth of a black hole from the direct collapse of galactic material, unmediated by the life and death of stars. The Infinity Galaxy thus became a kind of cosmic Rosetta Stone, offering a translation between the universe's visible beauty and its invisible machinery. What stunned researchers even more was the elegance of the structure around the chaos. Despite the devastation, the two galaxies had woven a bridge of stars and dust between them, as if gravity were sculpting art from destruction. Streams of matter stretched for tens of thousands of light years, curving gracefully into the shape of infinity itself, symbolizing both endlessness and inevitability, the perpetual cycle of creation and collapse that defines the cosmos. Simulations now suggest that this is how many of the universe's earliest supermassive black holes may have formed, not through the death of ancient stars but through the merging of dense gas-rich systems that collapsed under their own weight. The Infinity Galaxy offers a time capsule of that process, allowing astronomers to peer into an era when the universe was still young and reckless, when its laws seemed flexible and its structures raw. The light Webb captured from this collision began its journey billions of years ago, long before Earth or even the Sun existed, and now it reaches us as a message from the dawn of complexity. That order itself can emerge from destruction, that chaos is not the enemy of creation but its instrument. Yet beneath the wonder lies unease. The brightness of the central region implies an energy output so extreme that no known process other than gravitational collapse could sustain it. The sheer efficiency of this event suggests that nature finds shortcuts when pressed, that the universe does not always play by its own rules. If black holes can form so suddenly, it would explain why we find them lurking in the earliest epochs of cosmic history, already fully grown when galaxies were still forming their first stars. It would mean that the seeds of darkness were planted not after, but alongside, the birth of light. Astronomers now suspect that such galactic collisions were once common, fiery encounters that shaped the early architecture of the cosmos. Each merger birthed not only new galaxies, but also the central singularities that would govern their evolution. The Infinity Galaxy stands as both a monument and a warning, a symbol of endless recurrence, where destruction and creation are merely two phases of the same eternal rhythm. It challenges the comforting notion that the universe evolves slowly and predictably. Instead, it tells us that reality is capable of sudden leaps, of violent transformations that rewrite everything in an instant. What we see as a graceful curve of starlight is, in truth, the signature of a cosmic catastrophe, an echo of infinite recursion. The figure eight etched across the heavens is not just an emblem of eternity. It is the shape of the universe's hunger, looping endlessly through birth and death, consuming and recreating itself without pause, and as Webb's instruments recorded the faint glow from this distant collision, one could not help but feel the symmetry of it all. Humanity, a transient species of stardust, watching through delicate machinery as infinity itself revealed its true face, beautiful, merciless, and unending. Drifting through the cosmic darkness like lonely sparks cast from forgotten fires, the rogue planets are among the strangest wanderers ever discovered. Unlike worlds tethered to suns, these planets roam freely through interstellar space, untethered, invisible unless they betray themselves through the faint warmth of their own residual heat or the rare reflection of starlight. For decades, they existed only as speculation, cosmic orphans ejected from the chaotic births of solar systems. But Webb's sensitive instruments turned that speculation into certainty, revealing not just single wanderers but pairs, binary planets, locked in one another's gravity, dancing through the void with no parent star to guide them. Astronomers call them jumbos, Jupiter-mass binary objects, and their existence rewrites the rules of planetary formation. Two massive planets, each comparable in size to Jupiter, orbiting one another in isolation. It is a phenomenon that should be nearly impossible according to our understanding of celestial mechanics. Without a star's stabilizing influence, such pairs should quickly drift apart, yet these duos persist, bonded across light years of emptiness by a delicate gravitational thread. They circle each other in perfect silent symmetry, their shared center of mass tracing a ghostly path through the interstellar medium. It is both haunting and poetic. Two worlds in perpetual embrace, lost in an endless night. But their romance is not the only mystery. Radio telescopes have detected faint emissions from some of these systems, whispering signals that pulse with uncanny rhythm. At first, scientists thought they might be artifacts or interference, but repeated observations confirmed their reality. These emissions likely arise from magnetic interactions between the paired planets, generating radio waves as charged particles spiral through their magnetic fields. In essence, these planets speak in electromagnetic murmurs across the void, cosmic lovers calling to one another through invisible storms. Such systems raise profound questions about how planets form and survive. Traditional models suggest that planets coalesce from the debris disks surrounding young stars, gathering material until gravity molds them into spheres. But these rogue binaries imply another path. Perhaps some were ejected together from collapsing stellar nurseries, their mutual gravity preserving their partnership even as they were cast out into the darkness. Others may have formed independently, condensing from solitary pockets of gas in the interstellar medium, proving that stars are not the universe's only architects. If planets can be born in isolation, then the boundaries between star and planet blur. The cosmos becomes a continuum of creation, with mass alone deciding whether an object shines or drifts unseen. The existence of jumbos also hints at hidden populations of smaller, colder worlds, perhaps billions of Earth-sized wanderers adrift between galaxies, unseen but not non-existent. They may carry frozen oceans beneath icy crusts, or atmospheres preserved by internal heat, sustaining conditions that defy our narrow definition of habitability. Some researchers suggest that rogue planets could even host life, powered not by starlight but by geothermal energy, protected within thick shells of ice. The notion that life could drift through interstellar space on such isolated vessels is both chilling and exhilarating. Webb's infrared vision has glimpsed a few of these nomads glowing faintly against the black, their heat signatures betraying temperatures just above absolute zero. Each one is a fragment of a lost solar system, a reminder that planetary birth is as violent as it is creative. During the early chaos of star formation, gravitational skirmishes fling countless worlds into exile, scattering them like cosmic debris. Most vanish into the dark, but some, by chance or design, find companionship, binding themselves to a twin for an eternity of wandering. These pairs move through regions where the nearest star may be trillions of kilometers away, where no sunrise will ever break their perpetual night. Yet they endure, and in their endurance lies a kind of defiance. The binary rogue planets are proof that order can persist even in isolation, that gravity's quiet loyalty outlasts chaos. They may even play a hidden role in galactic evolution, stirring interstellar gas as they pass, seeding turbulence that shapes future stars. Their faint radio voices add another layer to the cosmic symphony, a chorus of worlds without homes. Humanity's telescopes have only begun to hear them, faint whispers echoing across the cold. It is easy to romanticize these wanderers, to imagine them as symbols of cosmic loneliness, but in truth they embody resilience. In a universe ruled by collapse and creation, they are the drifters that survive both. Somewhere, between galaxies, two planets circle each other still, their orbits carved into eternity, unseen and unending, carrying with them the quiet reminder that even in the deepest darkness, gravity can still bind, and motion itself can become a form of a love. In the vast interstellar nurseries where new worlds are forged from clouds of dust and gas, Webb has uncovered a riddle that strikes at the heart of planetary science, a paradox of chemistry that challenges everything we thought we knew about the building blocks of life. Around young stars, astronomers expected to find protoplanetary disks rich in water vapor and organic molecules, the essential ingredients for habitability. Yet what Webb's sensitive instruments revealed instead were regions heavy with carbon dioxide but shockingly poor in water. These planet-forming disks, shimmering like halos of frozen fire, appear chemically inverted, their molecular recipes rewritten by some unknown process. In the classical picture of creation, water condenses easily in the cooler outer zones of disks, coating grains of dust that later combine into comets, moons, and planets. Oxygen should dominate these early environments, setting the stage for oceans and atmospheres. But the spectra that Webb collected from systems hundreds of light-years away tell another story. Carbon chemistry reigns supreme. Carbon dioxide and other carbon-bearing compounds appear in abundance, while water vapor, the molecule we once assumed ubiquitous, is scarce. This is not merely a local oddity. It appears to be a universal trend across multiple stellar nurseries. Something fundamental in the chemistry of planetary birth has been misunderstood. Perhaps the ultraviolet light from young volatile stars is breaking apart water molecules faster than they can form, leaving behind an excess of carbon compounds resilient enough to endure. Or perhaps these disks began with an inherently different chemical balance, their parent clouds lacking the oxygen needed to produce water. Either way, the implication is sobering. Many planets may form dry, sterile and carbon-rich from the beginning, worlds sculpted from ash rather than ice. That revelation forces scientists to reconsider the timeline of habitability itself. If water is not guaranteed during formation, then it must arrive later, delivered by comets or icy debris long after a planet's birth. Earth's oceans, once thought to be a natural byproduct of its creation, might instead be the result of cosmic luck, a series of collisions that delivered just enough frozen cargo from the outer solar system. The rarity of water-rich disks implies that truly wet worlds like ours may be less common than hoped. Even more unsettling, the carbon-heavy environments Webb observed could lead to exotic chemistries we can scarcely imagine. Planets born in such conditions might possess methane-dominated atmospheres or surfaces coated with hydrocarbons instead of minerals, their skies tinted in strange hues, and their geology driven by entirely different rules. Some may be rich in organics yet devoid of water, paradoxically fertile in molecules but barren in life. For astrobiologists, this is both thrilling and frustrating. The cosmos seems more inventive than we are capable of modelling. The presence of abundant carbon dioxide without corresponding water lines also suggests intense stellar radiation sculpting these disks. Ultraviolet and X-ray bursts from young stars could strip away lighter molecules, sterilizing the environment before planets even have the chance to form. In some regions, Webb detected cavities within the disks, vast gaps where radiation pressure or magnetic storms may have blown away volatile materials entirely. These processes hint at a universe that does not nurture easily. It must be coaxed into generosity, yet within the harshness lies creative potential. The same radiation that destroys water can also trigger complex chemical reactions, forging prebiotic compounds that could later seed life under more favorable conditions. In this way, destruction becomes an agent of possibility. Perhaps every world must first endure sterilization before it can host life. A cosmic trial by fire that ensures only the most resilient chemistries survive. Webb's data remind us that life's ingredients are not evenly distributed, but instead the outcome of violent balances. Light against shadow, creation against decay. The chemical paradox it revealed may be the rule rather than the exception, a glimpse into how diverse and unpredictable planetary systems truly are. In some disks, faint signatures of silicates and carbon dust hint at the early assembly of rocky planets, suggesting that even without water, solid worlds still emerge. But these planets will be alien beyond comprehension, their crusts infused with graphite and soot, their atmospheres thick with carbon dioxide, their seas, if any exist, boiling under crimson skies. Such worlds will challenge our definitions of habitability and even our understanding of what it means for a planet to be alive. The universe, it seems, is far less concerned with our preferences for water and oxygen than with the raw artistry of chemistry. Each new discovery from Webb blurs the boundary between the habitable and the hostile, reminding us that life, if it exists elsewhere, may arise under conditions we would find utterly toxic. The chemical paradox is not a failure of nature to conform to our expectations. It is proof that nature's imagination far exceeds our own, that the cosmos composes its symphonies in unfamiliar keys, and that somewhere among these carbon-rich worlds there may still be melodies we have yet to hear. Among the strangest of all worlds ever found by Webb's relentless eye is a planet that should not exist, a sphere of molten agony wrapped in the thin shimmer of an atmosphere that refuses to die. This infernal world, known as 55 Cancri E, orbits so close to its star that its surface glows with the heat of a forge, its dayside a sea of liquid rock and vaporized minerals. Temperatures there soar beyond 2,000 degrees Celsius, enough to melt iron, vaporize granite, and turn every element we know into a churning plasma. Logic dictates that no atmosphere could survive such punishment. It should have been stripped away long ago by the star's searing radiation and relentless stellar winds. Yet Webb's instruments have confirmed the impossible. Spectral readings reveal gases swirling above the molten surface, shifting and reforming in an unending cycle of destruction and renewal. It is as if the planet breathes fire. Each day, as the star's radiation pounds the exposed hemisphere, volatile compounds are torn apart, their atoms scattered into space. Each night, as the dark side cools by only a fraction, molten rock releases new gases into the sky, recreating what the star destroyed. This rhythm of annihilation and rebirth has transformed 55 Cancri E into a cosmic paradox, a hell that persists through regeneration. Scientists once imagined that close-orbiting rocky planets must be sterile, bare cores left after their atmospheres boiled away. But this discovery reveals that even in the most extreme environments, nature finds a way to maintain balance, not stability, but a dynamic equilibrium that defies simplicity. The gases Webb detected, likely carbon monoxide and silicon-bearing vapors, suggest an atmosphere forged directly from the planet's molten oceans. Each eruption and convection current beneath the surface injects fresh material upward, feeding a veil of vapor that may last mere hours before being stripped away again. The process is violent, constant, and cyclical, like a planet eternally exhaling its own skin. This revelation has rewritten models of atmospheric evolution. It suggests that volcanic outgassing, once thought a secondary mechanism for atmosphere formation, can dominate under extreme conditions, providing a self-sustaining feedback loop that preserves a gaseous envelope even in the face of stellar brutality. In this world of molten rivers and vapor storms, air and rock are not separate domains but parts of the same restless continuum. Imagine standing on that planet's twilight edge, where the molten horizon meets a blackened sky. You would see metal rain falling like molten glass, oceans glowing crimson beneath veils of vapor that shimmer with faint luminescence. Every gust would carry the scent of ash and iron, and the ground would flow beneath your feet. 55. Cancri E is locked tidally to its star, showing one face eternally to the light and one to the dark, a cosmic Janus divided by heat and shadow. On the day side, the atmosphere is constantly stripped and ionized. On the night side, it condenses and reforms, flowing back like a planetary tide. The result is a ceaseless circulation of matter between solid and gas, rock and air, death and rebirth. It is a planetary system in perpetual motion, not toward life, but toward endurance. For scientists, this discovery offers clues about the early Earth, when our own world glowed with magma oceans and volcanic plumes, sculpted the first primitive atmosphere. In the fury of 55 Cancri E, we glimpse our planet's forgotten youth, a reminder that stability is a late luxury in the story of creation. The survival of this atmosphere under such hostile conditions suggests that other close-orbiting worlds, once dismissed as lifeless, might also harbour dynamic layers of gas. Some could even maintain thin films of volatile compounds capable of chemistry, though not biology, bridging the gap between geology and atmosphere in ways previously unseen. The lesson is humbling. Habitability is not the only measure of significance. Even worlds of fire can teach us about balance, transformation, and resilience. Webb's infrared eyes capture the faintest details of this inferno, subtle shifts in emission lines that trace the heartbeat of the planet's atmosphere as it dies and is reborn each day. The data reveal winds racing at thousands of kilometers per hour, carrying vapor from one hemisphere to the other in a desperate attempt to equalize extremes. Beneath that chaos lies order, an elegant physics of equilibrium through suffering. 55. Cancri E, the hell planet with an atmosphere, stands as a symbol of cosmic persistence, proof that existence can adapt to any torment the universe inflicts. It is not a world of hope, but of endurance, a reminder that creation is not gentle, that beauty often hides in the places where everything should fall apart. Somewhere out there, this molten sphere still circles its relentless star, its surface boiling, its sky shimmering, breathing in and out through waves of fire, keeping its fragile identity intact against all odds. From the distant darkness beyond our solar system came a wanderer older than the sun itself, a messenger of ancient time drifting silently through the interstellar abyss. Astronomers named it 3I Atlas, the third known interstellar object to visit our cosmic neighborhood, but that sterile designation fails to capture its staggering significance. This icy traveller was born long before the planets of our system had coalesced, forged in the cold nurseries of another star, perhaps even in a galaxy that no longer exists in the form it once did. Webb's instruments, designed to read the chemical signatures of light billions of years old, reveal that 3I Atlas carries within it material untouched since the earliest epochs of cosmic history. Its composition, a mix of exotic ices, complex hydrocarbons, and isotopic ratios unseen in our local system, marks it as an artifact from a time when the universe itself was young. Every grain of dust within it is a relic of processes that predate our own sun by eons. The comet's orbit, hyperbolic and unbound, confirms that it is a true interstellar nomad, merely passing through, unaffected by the sun's gravity, a ghost sweeping across the borders of our celestial family. It came hurtling inward from the void, its trajectory whispering of the systems it had once known, the stars it had passed and the collisions it had escaped. As it approached the inner solar system, Webb turned its gaze upon it, capturing spectra that read like the autobiography of a universe, faint signatures of water ice, ammonia, and organic compounds that have survived billions of years in the deep freeze of interstellar space. 3I Atlas is not merely a comet, it is a time capsule. Within its frozen shell lie the chemical fingerprints of an era before the Milky Way had even stabilized its spiral arms, before any life stirred anywhere. Its discovery is akin to unearthing a fossil older than the Earth itself, drifting free between the stars. The data suggest that its ice contains a higher ratio of heavy isotopes than those found in typical solar system comets, indicating formation in an environment much colder and more distant than our Sun's birthplace. Such details hint that the molecular recipes for life, carbon chains, nitrogen compounds, prebiotic precursors, were widespread across the cosmos long before any planet called Earth existed. The arrival of this interstellar traveller forces us to reconsider the origins of life's ingredients. Perhaps the building blocks of biology are not local miracles but galactic currency, scattered across star systems by comets like Atlas, exchanged endlessly between newborn suns. If so, life itself may be a communal enterprise of the cosmos, seeded and reseeded by ancient messengers wandering through eternity. The sight of 3I Atlas glowing faintly as it passed through the sunlight was both beautiful and mournful. Its coma shimmered with emerald light, a product of cyanide and carbon compounds vaporizing as it neared the sun, releasing gases that had been trapped for billions of years. For a brief moment, this ancient wanderer illuminated our skies before fading back into the abyss. Its visit was fleeting, yet in that short time it offered a direct link to the universe's distant past, a reminder that even as stars burn and die, matter remembers. Webb's analysis of its tail revealed molecules never before observed in any solar system object, evidence of chemical pathways that may only occur in the deep interstellar medium. These compounds, when compared with the chemistry of Earth's oldest meteorites, suggest that some of the organic material that seeded our own planet may have come from similar messengers eons ago. The notion that life's potential was carried to us on icy fragments of long-lost worlds blurs the boundary between origin and inheritance. We are perhaps the descendants of interstellar debris. The trajectory of 3I Atlas also provides clues about the architecture of other star systems. Its speed and angle of approach suggest it was flung from its home by a gravitational encounter, perhaps with a giant planet or a binary star billions of years ago. Since then, it has wandered the galaxy in solitude, untouched, unchanged, until fate brought it momentarily within human reach. In its journey, it has likely crossed vast stretches of the Milky Way through radiation storms and magnetic fields, collecting the scars of time upon its icy skin. To study such an object is to peer into the history of the galaxy itself, for comets like this are storytellers that speak in the language of chemistry and motion. As it departed the sun's realm, fading into the darkness once more, 3I Atlas left behind no trace but data, light converted into numbers, numbers into understanding, and yet that understanding is profound. The realization that the universe keeps its history not in libraries or monuments, but in fragments of ice and dust drifting between stars. The ancient messenger has gone, but the story it carried remains, a story of persistence across eons, of memory preserved in frozen silence, and of a cosmos that never truly forgets. When Webb's mirror first opened its golden eyes upon the distant cosmos, it began to reveal objects so small, so dim, and so impossibly ancient that astronomers initially dismissed them as image artifacts, mere errors of light. But as the data accumulated, a pattern emerged, hundreds of compact crimson points scattered across the earliest epochs of the universe, glowing faintly against the black. These became known simply as the little red dots, though the simplicity of the name masks the enormity of their implications. Each of these dots is an object billions of light-years away, its light stretched into deep red wavelengths by the expansion of space itself. They exist at a time when the universe was less than 1 billion years old, yet their brightness and density suggest something far beyond the small primitive galaxies that theory predicted. Some appear to be galaxies compacted into volumes a fraction the size of the Milky Way, yet containing masses equivalent to tens of billions of stars. Others defy even that classification, too luminous, too concentrated, too energetic to fit any known model. What then are they? One hypothesis holds that these dots are the homes of the universe's earliest supermassive black holes, still wrapped in cocoons of dust and gas, their fierce radiation filtered into red hues by cosmic distance. In that scenario, we are witnessing the infancy of quasars, black holes forming before galaxies fully assembled around them, their gravity already shaping the young universe like invisible sculptors. Another, more radical idea suggests that these may not be galaxies at all, but entirely new types of structures, born from unknown processes during the cosmic dawn. The sheer number of them, hundreds detected within just a few Webb fields, challenges every assumption about how quickly matter could organize itself. If each red dot corresponds to a massive black hole, then the early universe was far more violent and efficient than anyone imagined, producing gravitational monsters faster than our physics allows. Yet their uniformity hints at something even stranger, a synchronized behavior on a cosmic scale. Their brightness ratios follow patterns eerily consistent across vast distances, as if bound by an underlying law we have yet to uncover. Some researchers have begun to wonder whether these objects are connected through mechanisms that transcend ordinary matter, perhaps shaped by fluctuations in the fabric of space-time itself. Webb's spectroscopy revealed that the light from several of the dots carries unusual signatures. Hydrogen emission lines broadened beyond expectation, suggesting velocities and densities inconsistent with known galactic models. Whatever these little red dots are, they are not quiet and they are not simple. Each one radiates a history written in wavelengths too ancient for human intuition to easily grasp. The discovery has reignited debate about the timeline of cosmic formation. If these compact systems existed so early, then galaxies and black holes must have grown together from the very start, entwined in mutual evolution rather than sequential order. That would mean the traditional hierarchy of cosmic development, first stars, then galaxies, then supermassive black holes, may be an illusion born of our limited vantage. The universe may have birthed its most massive objects simultaneously with its first lights. The red dots, in this view, are embryonic galaxies incubated around rapidly feeding black holes, their glow the result of unimaginable violence hidden behind veils of dust. Webb's images show faint halos around some of them, as if light were leaking from structures too small to resolve, hinting that we may be glimpsing the very seeds from which modern galaxies evolved. Others, however, show no halo at all, just a perfect unresolved sphere of red, suggesting something far denser and more compact. Theoretical physicists have speculated that these could be dark stars, hypothetical objects powered not by fusion but by the annihilation of dark matter within their cores. If true, that would mean we are seeing the universe's first generation of luminous objects, not stars, not galaxies, but something entirely new. The little red dots would then represent a transitional phase of existence, a bridge between the invisible and the visible, between dark matter's reign and the birth of ordinary matter. The implications are staggering, that the first sources of light in the cosmos were powered not by the chemistry of atoms, but by the death throes of the universe's most mysterious substance. And even if that idea proves false, the mystery remains. Each dot, each faint point of ancient light, is a window into an era when the rules of creation were still being written. The Webb telescope, by revealing them, has given us a glimpse of a time before the familiar architecture of galaxies took shape, a glimpse of the universe as it was just learning how to shine. To look upon the little red dots is to stare at the alphabet of existence itself, each glowing point a letter in the language the cosmos used to speak itself into being. As Webb continued to map the heavens with unrelenting precision, astronomers began to notice a subtle pattern emerging across the tapestry of galaxies, a rhythm too coherent to dismiss, a quiet order hidden within apparent randomness. When plotted on vast scales, thousands of galaxies seem to share a preferred orientation, their rotations leaning in the same direction as though the entire cosmos itself was slowly turning. This discovery, tentative at first, grew more compelling with each new survey. Galaxies separated by billions of light-years appeared to spin in synchrony, their angular momentum aligned like dancers in a cosmic waltz, choreographed by an unseen hand. In a universe long believed to be isotropic and uniform, such coherence should not exist. According to the cosmological principle, there is no up or down, no axis around which everything moves. The universe should look the same in every direction. Yet the data whispered otherwise. Webb's deep field observations, combined with polarization studies and redshift mapping, began to trace faint spiraling patterns across the celestial sphere, suggesting that the cosmos might possess a global rotation, an almost imperceptible twist woven into the very fabric of space-time. If this is true, it would mean that the universe is not expanding in perfect symmetry, but spinning like a colossal gyroscope, its axis stretching beyond comprehension. Such a revelation would overturn the foundational assumptions of modern cosmology. A rotating universe could explain anomalies that have puzzled scientists for decades. The uneven distribution of galaxy clusters, the curious alignment of the cosmic microwave background's cold spot, and even the peculiar motion of dark matter filaments threading through intergalactic space. Some theorists propose that this rotation might be a remnant of the universe's birth, a faint echo of angular momentum conserved from the Big Bang itself. Others suggest that it could arise from interactions between higher dimensions, where our three-dimensional cosmos is embedded within a larger spinning structure, a cosmic whirlpool of realities. The very idea feels heretical, for it challenges the comforting image of a uniform, directionless universe, replacing it with something dynamic, asymmetrical, and alive with motion. Webb's ability to detect the faint polarization of ancient light allowed researchers to measure subtle anisotropies in the background radiation, patterns that, when mapped, resembled spirals rather than random noise. This spiral imprint might be the fingerprint of cosmic rotation, faint yet undeniable. If so, the implications ripple outward to everything we know. A rotating space-time would generate frame dragging on a universal scale, meaning that even empty space would twist as it expands. Light travelling across such a cosmos would subtly curve, and time itself would experience tiny directional biases. Over billions of years, these infinitesimal effects could shape the distribution of galaxies, imprinting order upon chaos. Some physicists have drawn parallels between this phenomenon and the rotation of black holes, whose spinning singularities drag space-time around them like whirlpools of reality. Perhaps they suggest the universe itself is a black hole, an immense rotating one, its event horizon corresponding to the boundary of cosmic visibility. In this view, what we call the observable universe is merely the interior of a vast rotating singularity born from some prior cosmos. The idea may sound fantastical, yet the mathematical echoes are hauntingly consistent. Rotation, it seems, may be the universe's most fundamental property, the hidden rhythm that underlies gravity, magnetism, and even the flow of time. Some astronomers resist the notion, arguing that the data could be statistical mirages or artifacts of selection bias. But with each new Webb dataset, the alignment persists, stubborn and quiet. It is not proof, but it is persuasion. And if the universe truly turns, then we must ask, around what? What lies beyond its axis, beyond the limits of what we can see? There may be no centre as we imagine it, only a direction of rotation, a cosmic vector pointing into the unknown. Philosophically, the notion is intoxicating. A rotating universe would mean that motion is not merely something that happens within the cosmos. It is something the cosmos itself performs. The dance of galaxies, the spin of planets, the rotation of atoms, all may be reflections of that primordial spin, echoes of an ancient motion that began before time could be measured. Webb's discoveries remind us that the universe may not be a static void, but a living mechanism, winding and unwinding through infinite scales. The stars trace this motion unconsciously, their spirals recording the memory of creation's first turn. Perhaps in some profound sense, everything rotates because the universe itself remembers that first cosmic spin. We too are caught in that rotation, our atoms, our world, our thoughts, drifting within a vast and elegant whirlpool whose edge no one will ever reach, yet whose motion shapes every heartbeat of existence. In the deep reaches of space, where galaxies shimmer like embers fading into the cosmic dark, Webb has uncovered two extremes of existence: insatiable monsters that devour everything around them, and colossal galaxies that have inexplicably fallen silent, frozen in eternal slumber. The first are black holes feeding at impossible rates, consuming matter so voraciously that the laws of physics seem to bend under the strain. The second are vast galactic structures that, for reasons unknown, have stopped forming stars altogether. Together they form a haunting duality, creation and starvation intertwined on a cosmic scale. When Webb's instruments observed the centres of certain young galaxies, it detected energy output so intense they could only come from supermassive black holes, consuming matter faster than theory allows. According to our understanding, the accretion process should reach a limit, the Eddington limit, beyond which radiation pressure pushes incoming material away. But these feeding monsters ignore that boundary. They gorge themselves on gas and dust, swallowing light itself, their accretion disks blazing brighter than entire galaxies. Some of these beasts existed when the universe was less than 1 billion years old, suggesting that black holes could grow far faster than any model predicts. Theorists scramble to explain their rapid rise. Perhaps they formed from the direct collapse of colossal gas clouds, skipping the star stage entirely. Or perhaps dark matter somehow aided their growth, funneling energy into the singularity in ways we do not yet understand. Webb's infrared data show their furious feeding clearly, matter spinning inward at relativistic speeds, heated to millions of degrees, creating jets that stretch across thousands of light years. These jets carve through interstellar space like cosmic lances stirring gas, triggering star formation in some regions while sterilizing others. Each black hole becomes both destroyer and creator, shaping its host galaxy through violence. Yet elsewhere, Webb finds the opposite, galaxies that have gone dark. These are the cosmic sleepers, systems that appear to have simply stopped making stars, their once bright spirals now cold and quiescent. In them, hydrogen gas, the raw material for starbirth, has vanished, consumed or expelled by long-past outbursts from their central black holes. These galaxies, though still massive and full of old stars, have entered a kind of cosmic coma. Their spectra show no trace of the young, hot stars that give galaxies their bluish glow. Instead, they shimmer faintly red, their light dominated by the dying embers of stellar populations born billions of years ago. Astronomers call them quenched galaxies, but the name hardly captures their eerie stillness. In Webb's high-resolution images, they appear almost perfect in form. Smooth, symmetrical, lifeless. No turbulence, no chaos, no new light. It is as though the universe itself has exhaled and forgotten to breathe again. How such galaxies can exist alongside furious growing quasars is one of the great puzzles of modern astrophysics. Perhaps the two phenomena are linked. When a black hole feeds too violently, it releases so much energy that it blows the surrounding gas out of the galaxy, halting star formation permanently. The same monster that grows at the centre may thus kill its own cradle, transforming a vibrant galaxy into a fossil of its former self. Webb's data hint at such feedback loops everywhere, the delicate balance between nourishment and annihilation that governs cosmic evolution. The feeding monsters and the sleeping beauties, as some romantically call them, are not opposites but stages in a single grand cycle. A galaxy feeds its black hole. The black hole awakens, radiates, and consumes until it chokes off its host's lifeblood, leaving behind a silent monument to its own hunger. Over billions of years, gravity may pull new gas inward, rekindling the process, and the galaxy may flare back to life once more. The universe, it seems, operates not as a linear progression of birth and decay, but as an endless oscillation between feast and famine. Even within death there is the potential for rebirth. Some of Webb's most haunting images show faint signs of residual gas drifting back into these dormant galaxies, like the first stirrings of breath in a sleeping giant. In time, they may awaken again, reigniting with new stars, proving that even silence in the cosmos is temporary. The contrast between these extremes, the gluttonous black holes and the comatose galaxies, tells a story of balance written across cosmic scales. Every act of destruction seeds creation, every stillness hides the memory of fire. The feeding monsters roar at the centre of existence, while the cosmic sleepers wait in the dark for the next spark, and between them lies the pulse of the universe itself, beating in cycles of violence and rest, hunger and peace, forever echoing the rhythm of life in the cold and endless void. Among Webb's strangest revelations lies a world that defies the very notion of weather, a planet where the skies glimmer with metallic storms, and rain falls not as water, but as molten iron. Known to astronomers as WASP 76b, this monstrous gas giant orbits its star so closely that one hemisphere forever faces the light, while the other remains trapped in perpetual darkness. On its day side, temperatures exceed 2,400 degrees Celsius, hot enough to vaporize metals into gaseous form. Winds howl at thousands of kilometers per hour, dragging clouds of vaporized iron from the scorching daylight into the frozen night, where temperatures plummet just enough for that vapor to condense and fall as iron rain. This cycle of evaporation and precipitation plays out on a planetary scale, a ceaseless storm of molten metal circling the globe. Webb's instruments detected spectral lines revealing iron atoms suspended in the atmosphere, a signature that confirmed what theory had long imagined, that worlds of fire and metal truly exist. To stand upon such a world, if one could, would be to witness the poetry of destruction. Horizons glowing gold with incandescent clouds, skies flashing with sheets of metallic lightning, and a constant drizzle of glowing droplets hissing against the planetary winds. It is a place where chemistry becomes art and violence becomes beauty. Yet WASP 76b is more than a spectacle. It is a window into the evolution of extreme planets. The dynamics of its atmosphere teach scientists how matter behaves under conditions impossible to reproduce on Earth. Its tidally locked rotation creates two drastically different worlds on one sphere, eternal day and eternal night, divided by a line of perpetual twilight where metals liquefy and the air itself shimmers. But even as Webb studied this infernal planet, another revelation emerged from far beyond, an image so surreal that astronomers first thought it a trick of perspective. Deep in the cosmic distance, Webb captured a galaxy shaped like an enormous glowing owl, its twin eyes the blazing cores of two merging galaxies, its outstretched wings composed of filaments of gas and stars stretching across millions of light-years. Dubbed the Cosmic Owl, this merger is among the most spectacular ever recorded. Each of its luminous eyes hides a supermassive black hole spiraling toward collision, their combined gravity warping the surrounding space into arcs of light. As they draw closer, torrents of matter stream between them, igniting bursts of star formation across their wings. It is a vision of both majesty and annihilation, a cosmic dance that will end in a singularity, yet produce millions of new suns along the way. Webb's infrared sensitivity revealed the intricate structure of this collision. Delicate tendrils of dust glowing faintly, vast waves of interstellar gas compressed by shock fronts, and tidal bridges connecting the two galactic cores like threads of cosmic silk. The symmetry of the owl is almost too perfect, as though nature were sketching art upon infinity. This is no static sculpture, however. It is a battlefield. Within a few 100 million years, the two black holes will merge, releasing energy on a scale that defies comprehension. The resulting gravitational waves will ripple across space-time, faint yet eternal, whispering of the union to every corner of the cosmos. The cosmic owl thus represents the universe's capacity to shape destruction into creation. Every time two galaxies collide, new stars are born, new elements forged, and new forms of order carved from chaos. And like the iron rains of WASP 76b, these events remind us that the universe is never idle. It transforms endlessly, recombining its elements in patterns both violent and sublime. The connection between the iron world and the owl-shaped galaxy is not merely poetic. Both embody the same principle of cosmic circulation. The iron atoms falling as rain on WASP 76b were once forged in the hearts of long-dead stars, ejected into space by supernova, and later gathered into new systems. The same cycle that shapes planets also drives galaxies. Matter destroyed becomes matter reborn. Webb's discoveries bind these distant scales together into one narrative. From droplets of molten metal to wings of colliding galaxies, all obey the same eternal chemistry. The universe, it seems, delights in mirrors. The microcosm echoes the macrocosm. The tempest of a planet reflects the turbulence of galactic creation. When we look at the cosmic owl, we are not just seeing light from distant stars, we are witnessing the universal logic that also beats within our own atoms. Both the iron world and the galactic owl exist because gravity and heat conspire to rearrange matter into beauty, because destruction, at every scale, is the price of transformation. The rain of iron and the wings of galaxies are, in truth, the same storm, one written on the surface of a planet, the other across the canvas of space-time itself. In the earliest ages of the cosmos, before galaxies had matured and the periodic table had found its rhythm, the first stars should have been simple, vast furnaces of hydrogen and helium, untainted by heavier elements. Yet Webb's gaze into the deep past revealed something that should not exist. Young stars gleaming with metals, galaxies enriched with iron, oxygen and silicon, long before such elements should have had time to form. This is the riddle of forbidden chemistry, a violation of cosmic chronology that defies the logic of stellar evolution. According to theory, the universe's first stars, population 3, contained no metals at all, for metals are born only through fusion and death. When these primordial giants exploded as supernovae, they seeded the void with the first heavy elements, enabling later generations of stars, planets, and ultimately life. But Webb's instruments have detected spectral lines belonging to these metals in galaxies formed when the universe was less than a few 100 million years old. It is as though creation skipped steps, fast-forwarding through epochs of nuclear alchemy. How could so many elements exist before the universe had enough time to make them? One possibility is that the first stars were far more massive and short-lived than expected titanic objects, hundreds of times the mass of the Sun that burned through their fuel in mere millions of years, detonating in cataclysms powerful enough to enrich vast regions of space almost instantly. If these primordial stars lived fast and died violently, they could have produced the metals Webb now sees shimmering in ancient light. Another explanation, even stranger, suggests that unknown processes, perhaps exotic particle interactions or dark matter annihilation, accelerated nuclear fusion in the universe's infancy, triggering chemical reactions forbidden by the physics we know. If true, the periodic table itself may have unfolded differently at the dawn of time. These revelations strike at the heart of cosmic history. The heavy elements detected in these infant galaxies are the same ones that build planets, oceans, and blood. They are the alphabet of matter, written too early in the story to make sense. In the faint glow of those ancient stars, we glimpse our own origins occurring ahead of schedule, as though the universe was impatient to create complexity. Some astronomers theorize that massive black holes forming in the first few 100 million years may have acted as cosmic forges, compressing gas and igniting nucleosynthesis in their accretion disks. In these extreme environments, gravity and radiation would collaborate to forge metals without the need for conventional stellar life cycles. Webb's spectrographs show chemical abundances that vary wildly between neighbouring regions, suggesting that metal enrichment was not gradual but explosive, spreading through space like sparks leaping from a fire. The forbidden chemistry Webb has uncovered is not a small discrepancy. It is an entire era of cosmic creation appearing where none should be. If the universe could generate heavy elements this quickly, then the seeds of life may have been planted far earlier than anyone dared imagine. Water, carbon, nitrogen. These compounds could have existed in nascent galaxies when the cosmos was still opaque with its own afterglow. In that case, the potential for life did not wait billions of years for calm worlds like Earth to appear. It may have begun wherever islands of stability briefly emerged amidst chaos. This realization collapses the comforting distinction between the early and mature universe, revealing instead a cosmos always pregnant with possibility. The term forbidden chemistry captures both the astonishment and the disquiet it provokes. It hints at physics we do not yet comprehend, perhaps new forces or particles influencing nuclear synthesis, or hidden dimensions altering reaction rates in the early plasma. Even the ratios of certain isotopes seem wrong, as though time itself flowed differently during those epochs of creation. In some spectra, elements appear overabundant in patterns that resemble the outputs of neutron star collisions events that should have been impossible so early. Could it be that matter found ways to mimic future processes before the actors even existed? Webb's data opens that door, and with every new observation, the universe seems to whisper that its creativity is boundless. The forbidden elements are not mistakes. They are evidence of cosmic artistry beyond our equations. Perhaps reality does not build itself through linear cause and effect, but through spontaneous bursts of innovation. The metals gleaming in those ancient stars are in a sense signatures of rebellion matter refusing to wait its turn in the grand sequence of creation. Each atom of iron in those first galaxies is a defiance of order, a declaration that the cosmos does not require permission to create beauty. In them we see the future written in the past, the fingerprints of life long before life itself had eyes to see. In the quiet reaches of our nearest stellar neighbour, something impossible has occurred. A planet that was once there has vanished without a trace. Alpha Centauri, long believed to host a stable and predictable system, now carries a mystery as profound as any in the galaxy. Astronomers had tracked the faint signal of a world orbiting one of its stars, a planet thought to be rocky, warm, and tantalizingly close to the habitable zone. Yet when Webb turned its unrivaled precision toward that familiar star, the signal was gone. No transit shadow, no gravitational tug, no spectral fingerprint remained. It was as if the planet had never existed. Some suggested it was an observational error, a ghost born from noisy data. But the records were consistent. Something had once been there and now was not. One hypothesis holds that the planet fell victim to gravitational instability, pulled apart by unseen forces or swallowed by its host star after a slow inward spiral. Another, more disturbing idea posits that the planet still exists, but has become invisible, cloaked by dense, magnetized plasma or enveloped in a reflective cloud of dust. Webb's instruments detected faint magnetic fluctuations emanating from the system, the kind that might accompany a catastrophic event or a radical transformation. Perhaps the planet underwent a phase shift, a process theorized but never observed, in which an atmosphere saturated with charged particles interacts violently with stellar magnetism, causing energy to accumulate until the world literally disintegrates, leaving only a magnetic echo behind. If so, the vanishing planet of Alpha Centauri may be the first known casualty of a phenomenon that links matter, energy, and magnetism at a level deeper than current physics can describe. Yet this mystery also illuminates a grander question. What role did magnetism play in the earliest days of the universe? For as Webb peers deeper into time, it reveals patterns of alignment and coherence across vast cosmic distances that suggest magnetic fields existed before galaxies, before stars, perhaps even before light itself. These primordial magnetic fields, faint but pervasive, could have acted as scaffolding upon which the first structures formed, guiding the motion of charged particles in the infant universe. Theorists long believed magnetism to be a secondary force, born of stellar processes, but Webb's data tell another story. Polarization patterns in ancient starlight reveal a cosmic web subtly magnetized, its filaments glowing with synchrotron radiation produced by electrons spiraling through magnetic fields billions of years old. It is as though the universe had a nervous system, an invisible network conducting the electric pulse of creation. These fields may have shaped not only the formation of galaxies but the behavior of matter itself, influencing how atoms combined and how plasma cooled after the Big Bang. In some regions they appear to form intricate brain-like patterns, vast filaments and nodes reminiscent of neural networks on a cosmic scale. The resemblance is not poetic exaggeration but mathematical fact. The distribution of galaxies along magnetic filaments follows fractal geometries similar to the structure of biological synapses. If magnetism indeed predates structure, then perhaps it serves as the universe's organizing principle, a silent architect guiding chaos toward order. The same force that once aligned dust grains in protoplanetary disks may have coordinated entire clusters of galaxies, ensuring that matter flowed along predictable currents. The vanishing planet of Alpha Centauri, in this context, becomes more than a curiosity. It is a microcosm of cosmic magnetism's power. Just as primordial fields shaped the large-scale universe, localized magnetic storms may shape the destinies of individual worlds. If a planet's magnetic field falls out of balance with that of its star, the result could be catastrophic: atmospheric collapse, orbital decay, or total disintegration. What we see as disappearance may simply be transformation, a world slipping into a state where our instruments can no longer perceive it. Webb's detection of polarized light patterns near Alpha Centauri hints at residual plasma clouds, perhaps remnants of a planetary core torn apart and dispersed. If so, the planet still exists, not as a globe of rock, but as a magnetic ghost, its atoms spread thin along invisible lines of force. It is a haunting reminder that magnetism, often overshadowed by gravity, may hold the key to understanding how the universe evolves and how it ends. The same magnetic threads that bind galaxies may one day unbind them, twisting space-time into new forms. From the disappearance of a single planet to the coherence of cosmic filaments stretching across billions of light-years, the message is the same. The universe is woven from invisible currents. Matter is merely their residue, and reality itself may be a grand magnetic field, humming eternally with the memory of its own creation. At the heart of the Milky Way, buried beneath clouds of dust and veils of ancient gas, there lies a monster that does not sleep. Sagittarius A, the supermassive black hole anchoring our galaxy, has long been assumed to be quiet, a cosmic relic resting after eons of consumption. Yet Webb's instruments, tuned to detect the faintest flickers of infrared light, have revealed something astonishing. Our galaxy's heart is pulsing. Every few hours, a surge of energy erupts from the region surrounding Sagittarius A, a rhythmic flare of radiation that rises and falls like the beat of a colossal heart. At first, scientists thought it random noise, the chaotic flicker of gas swirling too close to the event horizon. But over months of observation, a pattern emerged. Not perfect, but persistent, like breathing. The black hole, it seems, has a pulse, a cycle of dormancy and awakening, as if it inhales and exhales the matter that drifts too near. These luminous outbursts, sometimes lasting only minutes, release as much energy as 1 billion suns. They ripple through the surrounding space, heating clouds of dust and triggering waves of star formation across the central region of the Milky Way. This revelation has transformed the way astronomers understand galactic dynamics. The core of a galaxy is not a silent anchor but a living engine, its rhythms shaping everything around it. Webb's infrared eyes have captured the glowing arcs of gas spiraling inward, brightening with each heartbeat as magnetic fields twist and snap like invisible lightning. The heartbeat is not only energy, it is information, an expression of the intricate dance between gravity, magnetism, and the mysterious substance we call dark matter. For surrounding our galactic center, invisible yet omnipresent, is a halo of dark matter that influences every star, every orbit, every pulse. Webb's measurements of stellar velocities near Sagittarius A reveal subtle anomalies. motions too erratic to be explained by visible mass alone. Something unseen is tugging at the stars, distorting their paths, perhaps even feeding the black hole itself. Some physicists now suspect that dark matter is not the passive inert substance it was once imagined to be, but an active participant in cosmic evolution. In the dense environment near the galactic center, dark matter may collide, decay, or even annihilate, releasing bursts of energy that feed the central black hole and sustain its heartbeat. If true, this would mean that galaxies live not just through gravity and baryonic matter, but through the secret life of the unseen. Webb's observations have detected faint gamma and infrared signals that may correspond to dark matter interactions, subtle flashes that occur in sync with the flares from Sagittarius A. This synchronization cannot be coincidence. It suggests that dark matter is woven into the same rhythm as the black hole's own cycles. Perhaps the heartbeat of our galaxy is not simply the product of falling gas, but the music of invisible collisions, the slow violence of dark matter tearing itself apart at the core. The idea is both beautiful and terrifying, that what we call darkness is not absence but motion, not emptiness but conflict. On larger scales, this hidden violence may explain the strange, sculpted structures of galaxies across the universe. Webb has observed halos of dark matter, distorting light from distant quasars, their gravitational lensing forming arcs and spirals that trace unseen turbulence. Some regions glow faintly in wavelengths no known process can produce, as though dark matter itself were radiating in agony or birth. In the cosmic voids between galaxies, faint ripples of energy hint at ancient battles, where streams of dark matter collided and annihilated long before ordinary matter ever formed stars. Even now, these echoes shape the fate of galaxies, feeding black holes, triggering bursts of formation, and sometimes silencing entire systems. Dark matter, it seems, is not the background of the universe but its bloodstream, and Sagittarius A may be its beating heart. The pulse we detect from our galactic center is not a random flicker of light but a sign of deep connection, a resonance between the visible and the invisible. Every flare that Webb records is a reminder that we are part of this rhythm. Our sun, our planet, every atom of our being orbiting within the cadence of this cosmic drum. Somewhere beyond human comprehension, dark matter flows like a silent ocean, shaping the destiny of galaxies and whispering through the fabric of space. And in the middle of it all, the Milky Way's heart continues to throb, slow, deliberate, eternal, a soundless rhythm echoing through billions of years, a reminder that even in the vast stillness of space, the universe is never truly still. Among the billions of galaxies Webb has observed, one stands apart as though it were a deliberate riddle written into the sky. Designated Sears 1739 by catalogue, but nicknamed the Time Warp Galaxy by astonished astronomers, it exists so far away that its light began its journey when the universe was only a few 100 million years old. Yet the images Webb returned were not those of a chaotic infant galaxy, barely learning to assemble itself. Instead, they revealed a structure of mature complexity, a spiral form, arms curving gracefully, a bulging, luminous core where older stars already glowed. According to every cosmological model, such order should have been impossible at that epoch. The early universe was a violent storm of collisions and growth, where galaxies were small, irregular, and raw. And yet here was Sears 1739, a full-grown spiral, billions of years too early, its symmetry mocking our equations. Some suggested that perhaps we were witnessing a trick of gravitational lensing, the light of a nearby system warped to look older than it was. But subsequent analysis of its spectral redshift confirmed the impossible truth. The galaxy truly belonged to that ancient time. Somehow, nature had built an island of order in an era of chaos. Webb's infrared instruments revealed another shock. The light from its stars showed signs of chemical maturity, the kind associated with generations of stellar evolution. This meant that not only had the galaxy formed quickly, but it had already lived long enough for multiple cycles of birth, death, and rebirth among its stars. It was as though time itself had run faster there, as if the galaxy existed in a bubble of accelerated evolution. Some physicists proposed that Sears 1739 might reside near a region of warped spacetime, perhaps the result of an early cosmic defect, a tear or twist left over from the universe's formation that altered the local flow of time. If true, it could mean that certain corners of the cosmos experience reality at different rates, each evolving to its own clock. Others speculated that we were seeing the effects of dark energy on a microscopic scale, compressing both space and history into a smaller frame. Whatever the cause, the time warp galaxy stands as evidence that the universe may not expand uniformly, but may ripple through pockets of distorted chronology, where cause and effect blur. Webb's data also revealed a more intimate mystery within that same region, a cluster of stars engaged in a spectacle both mesmerizing and horrific: stellar cannibalism. In the core of a nearby galaxy, two suns were found locked in a deadly embrace. One was a red giant swollen in its final stages of life. The other, a smaller but denser companion, had begun to siphon its partner's outer layers through gravity's relentless pull. Streams of glowing plasma arched between them, forming luminous bridges of matter that spiraled inward, feeding the smaller star until its own surface erupted with bursts of fusion. Webb's infrared vision captured these jets of light as they pulsed rhythmically, synchronized with the orbital dance of the doomed pair. Over time, the larger star will be stripped to its core, its lifeblood stolen, until nothing remains but a faint remnant, a white dwarf circling the cannibal that consumed it. Such interactions are not rare in the universe, but never before have they been seen with such clarity, their violence rendered in spectral detail. The process of stellar cannibalism is both grotesque and creative. As one star dies, it fuels another, releasing waves of energy that seed nearby regions with heavier elements. Death feeds life. Consumption becomes creation. And perhaps that principle mirrors the larger cosmic truth of the time warp galaxy itself, a region where cycles repeat at unnatural speeds, where stars devour and renew one another in compressed epochs. It may be that time flows differently there, not because of any defect in the universe's structure, but because matter itself accelerates its own story through feedback loops of energy and collapse. In such a place, evolution would not require billions of years. The rhythm of creation could quicken until galaxies matured before their cosmic peers even took shape. Webb's images of these phenomena, the serene spiral of Sears 1739 and the feral beauty of stellar cannibalism, together compose a portrait of contradiction, harmony and violence, timelessness and decay. They reveal that the cosmos is not a linear sequence of events, but a vast improvisational composition where tempo varies, where some verses are whispered while others are shouted. The time warp galaxy, spinning quietly at the edge of time, is a reminder that reality may not be uniform, that each region of space could carry its own symphony of duration. And in the heart of that symphony, stars consume stars, light eats light, and creation itself moves to rhythms no human clock can measure. Before galaxies sculpted the sky, and before the first stars burned their signatures across the dark, there was a time when the universe glowed with a dim, featureless light, a soft afterglow of creation itself. This ancient radiance, stretched and cooled by the expansion of space, became what we now call the cosmic microwave background, the oldest light in existence. But Webb, with its infrared vision extending beyond the reach of any instrument before it, has begun to uncover something even fainter, whispers beneath that ancient glow, subtle fluctuations and spectral echoes that may belong to a time earlier still, when the universe was neither transparent nor dark but something in between. These echoes of the first light are not simple photons scattered from early plasma. They are remnants of the universe's first attempt at illumination, the moment when chaos began to think in terms of order. Webb's detectors have recorded faint ripples of radiation that cannot be explained by known processes of recombination or cosmic expansion. Their frequencies suggest that they come from the epoch before the first atoms formed, a time when light could not travel freely because it was trapped in an ocean of charged particles. To detect even a hint of such light is to peer into a forbidden era, the age of primordial radiation, when the laws of physics as we know them were still taking shape. The data hint that quantum fluctuations in the fabric of space-time itself may have emitted these protophotons, faint energy seeds that later became the scaffolding for stars and galaxies. In this view, light did not emerge from matter. Matter emerged from light. The echoes Webb has detected may thus be fossils of consciousness itself, the universe learning to see. Some patterns in this radiation resemble harmonic waves, repeating intervals that correspond eerily to the distribution of today's large-scale structures. It is as though the universe hummed a note at the beginning of time, and that resonance still vibrates through everything that exists, through galaxies, through atoms, through us. When plotted, these frequencies form a spectrum with peaks that follow a mathematical sequence known from quantum acoustics, suggesting that the early universe oscillated like a vast resonant chamber. In a sense, the cosmos began not with an explosion, but with a tone, a vibration that carried the potential for all structure. Webb's findings hint that this cosmic harmony may have influenced how matter gathered, how stars ignited, and how gravity sculpted the void into filaments and nodes. Every atom of carbon and iron, every drop of water and trace of oxygen is part of that first song condensed into form. The echoes of the first light, as researchers have come to call them, might therefore represent the oldest form of order the universe ever expressed. Some physicists propose that these early oscillations could even encode information, not random noise, but a pattern imprinted by the laws of quantum gravity during the Planck era, when the universe was smaller than a proton yet infinite in potential. If we could decode those signals, we might glimpse the handwriting of creation, the mathematical grammar from which all existence descends. Webb has detected faint modulations, alternating bright and dim bands, that repeat across different sky regions, their symmetry too perfect to be coincidence. Could these be the fossil remains of quantum entanglement on a cosmic scale, the memory of the universe's original unity before it fragmented into time and space? The idea stretches reason, yet the data persist, inviting interpretations that border on the mystical. Perhaps what we see in these echoes is the universe remembering itself, a reflection of its own birth reverberating across eternity. To look at this faint radiation is to experience something profoundly humbling. We are not merely observing the cosmos, we are listening to its first heartbeat. The photons Webb captures began their journey more than 13 billion years ago, yet they carry information about moments even older, when time itself was a newborn concept. And though they arrive to us faint and tired, stretched to near invisibility, they still speak of that first instant when the universe went from silence to sound, from potential to existence. In the face of such evidence, even the distinction between physics and poetry begins to dissolve. The cosmos was not born as chaos but as music, structured vibration becoming light, light becoming matter, matter becoming life. The echoes of the first light remind us that creation was never a single event but an ongoing song, one that began in frequencies no ear could hear, yet continues to resonate through every particle, every star, every human heart that dares to listen. Far beyond the familiar lattice of galaxies, past the shimmering filaments of the cosmic web and the faint hum of background radiation, Webb's data has revealed something that defies both geometry and imagination. A movement without source, a cosmic migration known as the dark flow. It began as a whisper among cosmologists, an unexplained drift detected in clusters of galaxies all moving in the same direction at immense speed, as though the entire visible universe were being pulled toward an unseen destination. For years, the phenomenon was dismissed as a statistical illusion, a quirk of incomplete data, but Webb's precision has erased all doubt. By mapping the velocities of thousands of galaxy clusters through their infrared signatures, it confirmed that this vast motion is real. Across billions of light years, matter moves coherently toward a single region of the sky, as if drawn by a force beyond the horizon of observation. The galaxies are not falling toward any known mass, nor are they following the flow of cosmic expansion. Instead, they move as though the universe itself is sliding across a surface invisible to us, as if space-time has a current. This motion violates the assumption that, on the larger scales, the universe should be isotropic and homogeneous. It suggests that beyond the limits of what we can see, something vast and gravitationally potent exists, perhaps another realm of matter, another universe, or the residual tug of a pre-Big Bang reality. Webb's refined measurements show that the direction of the dark flow aligns eerily with the so-called cold spot in the cosmic microwave background, an anomaly long believed to be random. Together they may mark the shadow of another cosmos pressing against our own, the bruise of a past collision between universes. If this interpretation holds, then the multiverse is not conjecture but geography, our universe just one bubble drifting in an infinite foam, still trembling from ancient contact. The edges of that collision could explain the uniform motion we now observe, the gravitational imprint of something beyond comprehension. Some theorists imagine this unseen attractor as a region where dimensions fold, a gravitational well leading into another space-time. Others propose that the dark flow is not movement toward anything, but away, a recoil from a tear in the cosmic fabric, where energy leaks into an extra-dimensional void. In either case, Webb's findings place humanity at the edge of an existential precipice. We are no longer at the center of creation, nor even within a stable, self-contained universe. We are passengers in a cosmic tide whose destination lies beyond physics itself. The implications are profound. If reality is indeed influenced by external forces from beyond its own boundaries, then the laws of nature may be local ordinances, not universal truths. Gravity, light, time, all may behave differently beyond that unseen horizon. Perhaps what we call the constants of nature are merely regional dialects in the language of existence. Webb's instruments, by extending our reach into deep infrared wavelengths, have begun to glimpse subtle distortions near the edge of the observable universe, faint lensing effects and anomalous redshifts that could be caused by space-time curving toward another domain. In one region, light from distant galaxies appears stretched not by expansion alone, but by directional tension, as though reality itself were being pulled taut. If space can stretch, perhaps it can also tear, and if it can tear, perhaps it can open. The dark flow may thus be more than a gravitational anomaly. It could be a message written into the motion of the cosmos, a sign that our universe is not infinite but connected, part of a greater continuum. This idea is both thrilling and terrifying. It suggests that the edge of our reality is not a boundary but a membrane, trembling from the pressure of whatever lies beyond. Webb's data cannot yet reveal what that beyond contains, only that it exerts influence. The galaxies, obedient to unseen gravity, drift toward it like iron filings toward a magnet whose pole lies outside the frame. We are in effect being drawn outward too, every atom and photon participating in this slow migration toward the unknown. Perhaps someday, far in the future, when expansion has carried us closer to that horizon, our descendants, if any remain, will witness its unveiling, the curtain lifting on whatever waits beyond. For now we can only measure and wonder. The dark flow is the universe's most tantalizing hint that we live not within the whole of reality, but within one eddy of a far larger ocean. It is the cosmic equivalent of hearing waves crash beyond a fog-shrouded shore. The edge of reality may not be the end at all, but the beginning of a greater structure, one that contains countless universes, each influencing the others through gravity, magnetism, or even shared dimensions of time. And in that vast architecture, our own cosmos drifts quietly, following the invisible current, like a leaf borne across a river too deep and dark to fathom. When Webb peered deeper into the void in search of galaxies at the dawn of time, it began to uncover something stranger than distance, repetition. Patterns of galaxies, clusters, and arcs of light appeared mirrored across opposite sides of the sky, as though the universe itself were reflecting its own image. Some configurations were nearly identical, twin spirals separated by billions of light years, yet sharing uncanny structural symmetry and spectral signatures. At first, scientists thought these duplications must be the result of gravitational lensing, the bending of light by intervening mass. But careful modelling revealed that in several cases no lensing body could explain the phenomenon. The implication was staggering. We might be witnessing a kind of cosmic reflection, a mirrored duplication of space and time across a hidden boundary. This led theorists to resurrect an old but radical concept, the mirror universe. According to this idea, our cosmos is only half of a larger whole, its twin existing on the opposite side of a cosmic divide, composed of matter that behaves in reverse. Time in that reflection would flow backward relative to ours, entropy decreasing as ours increases, so that together both universes preserve perfect symmetry. In such a model, the Big Bang was not a single explosion but a mirror event. Two universes born simultaneously from one singular origin, expanding in opposite temporal directions. Webb's detection of mirrored galactic patterns lends weight to this notion, suggesting that the symmetry of physics may extend beyond equations into the architecture of reality itself. Some data even hint at faint interference patterns, quantum echoes, where light from both sides might overlap, subtly reinforcing or cancelling each other across the boundary of space-time. These overlapping regions, minute and rare, could be responsible for unexplained anomalies in cosmic background measurements, flickers of brightness and darkness that defy statistical noise. If the mirror universe exists, it would mean that every particle, every atom, every human has a counterpart existing in reverse, bound not by physical contact but by perfect opposition. The mirrored cosmos would not be visible in the conventional sense, because its time axis runs contrary to ours. Light emitted there moves away from our future into its past. Yet quantum mechanics hints that the two realms could still communicate at the subatomic level, through entanglement that transcends time's arrow. Experiments on Earth have already shown that entangled particles seem to share information instantaneously, as though ignoring the separation of both space and time. Now, with Webb's far-reaching observations, physicists suspect that this phenomenon may not be limited to microscopic scales. It could be a property of the entire universe. The mirrored sky, then, might not be a visual illusion but a quantum reflection of reality itself, each side resonating with the other in an internal dialogue across time. Such an interpretation redefines causality. What we perceive as the future may be, in part, the consequence of events unfolding in that reverse domain. The mirror universe would thus serve as both counterpart and balance, ensuring that total energy, charge, and entropy across the multiversal whole remain conserved. Some even propose that dark matter, that invisible mass composing most of the universe, might actually be the gravitational imprint of matter existing in the mirror cosmos. We cannot see it because its photons move backward in time, but its gravity still presses against ours through the shared curvature of space-time. This elegant idea ties together some of cosmology's deepest mysteries, the missing mass problem, the asymmetry of time, and the near-perfect uniformity of physical laws, within a single framework. Webb's data, while far from conclusive, seems to dance around this truth. The distribution of galaxies at the farthest observable distances forms shapes that, when mathematically inverted, align precisely with those on the opposite side of the sky. The universe, it seems, might be looking at itself. Philosophically, the implications are staggering. If time truly flows both forward and backward in the grand design, then the distinction between beginning and end dissolves. The birth of the universe could also be its death seen from the other side, an infinite feedback loop of cause and effect chasing its own tail. Perhaps what we call the arrow of time is merely our perception within one half of this dual creation, while from the mirror side we are the ones moving backward. Webb's observations have thus reopened one of humanity's oldest questions. What is time? Not a river perhaps, but a mirror. Two reflections moving apart, each giving meaning to the other. In the silence between them lies everything we know. The mirror universe, whether literal or metaphorical, reminds us that existence may be defined not by separation but by symmetry. What happens here may echo there, across the invisible divide as both realms continue to unfold, one remembering, the other forgetting, yet together composing the infinite balance that keeps reality whole. For all its vastness and mystery, the universe has always carried within it a promise that one day even the darkness would end. The story told by Webb's golden mirror, the greatest eye humanity has ever opened, is not only one of beginnings, but of inevitable transformation. In the deepest reaches of space, beyond the farthest galaxies and the most ancient light, the telescope has glimpsed what may be the universe's final metamorphosis, the slow fading of shadow into light, the end of cosmic darkness itself. It began with faint signatures at the edge of observability, diffuse waves of infrared glow spreading across regions once thought utterly empty. At first, astronomers assumed this was background noise, the afterglow of the Big Bang or stray radiation from intergalactic dust. But as Webb's instruments gathered more data, the pattern became undeniable. Something in the deep voids was shining, not from stars, not from galaxies, but from the very fabric of space. These were not photons in the ordinary sense, they were the whispering decay of darkness, energy born from the death of cold. The universe, it seems, is quietly rekindling itself from within. For billions of years, cosmic expansion has stretched and thinned all things, pushing galaxies apart and cooling the intergalactic medium toward absolute zero. Yet Webb's observations suggest that even in the absence of matter, the vacuum itself is restless. Quantum fields tremble, particles flicker into and out of being, and in those fluctuations faint light emerges, the twilight of existence transforming into dawn. This spontaneous radiance, predicted in whispers by theory but never before observed, may represent the final phase of cosmic evolution, the re-illumination of the void. It is the universe's own afterlife, born from the decay of entropy itself. In this future, trillions of years ahead, stars will die, galaxies will dissolve, and black holes will evaporate, releasing their last energy as whispers of Hawking radiation. Yet even that will not be the end. The data Webb now collects hints that the vacuum's faint glow may intensify as the cosmos continues to expand, an inversion of expectation where darkness breeds its own undoing. The emptier the universe becomes, the brighter it will grow, until at last matter and energy are indistinguishable, and the boundaries between light and void vanish entirely. The end of darkness, then, is not a catastrophic finale, but a quiet transfiguration, a universe shedding its skin to reveal what it has always been, pure energy, pure possibility. And perhaps, in that distant age, the cycle will begin again. The laws of thermodynamics demand balance. Every decay must birth renewal. The photons released in that far future glow could, through quantum fluctuations, seed a new cosmos, one that rises out of the ashes of the old like a wave cresting upon itself. The cosmos, ever recursive, may be its own phoenix. Webb's discoveries already hint at this cyclicity. The echoes of the first light mirror the whispers of the last. The same quantum tremors that birthed the universe at its beginning still pulse in its expanding edge, binding alpha to omega in a single continuum. What we call time may merely be the breath between creation and recreation, exhalation and inhalation, darkness and dawn. Humanity, standing at the midpoint of that breath, witnesses both directions at once, the memory of light's birth and the prophecy of its return. The universe is not dying, only changing its form. Even now, as Webb's images arrive from the farthest corners of space-time, they reveal an exquisite symmetry. Galaxies forming where none should be, light persisting where it should fade, and patterns recurring across unimaginable distances. These are not coincidences but preludes. The cosmos does not collapse into silence. It transforms into music beyond hearing, light beyond sight. The end of darkness is not the extinguishing of the night, but its revelation as light unseen. And within that revelation lies the final, humbling truth, that nothing is ever truly lost. Every atom, every photon, every fleeting thought participates in a continuum without beginning or end. The universe remembers itself through us, through the instruments we build, through the questions we dare to ask. Webb has shown us that even the void is alive, that emptiness hums with creation's residue, and that beyond the black horizon, new dawns are waiting to unfold. One day, long after the last stars fade and the last observers vanish, light will rise again, not as starlight, but as the intrinsic shimmer of reality itself. The universe will glow once more, eternal and self-aware, the darkness transmuted into brilliance. The cycle will close only to open again, and in that endless rhythm, that pulse of being and becoming, lies the quiet, astonishing answer to everything. There is no true darkness, only light waiting to remember itself.